Howdy, y'all. Welcome to your negative exponents notes. We are in Unit 6, Lesson 3, and I hope you brought extra positivity with you today, because today's going to get real negative. By the end of the day, you'll be able to simplify expressions containing negative exponents. So let's look at what happens when we get negative exponents, and let's try to find a pattern here. As I look at these guys, and I look at the exponents over here, I notice they go 3, 2, 1, 0, -1, -2, and so on. So the exponent each time decreases by 1. Decreases, that means goes down by 1 on each step. Okay, right? So each time 3 goes to 2, 2 goes to 1, 1 goes to 0, etc., etc. On the other hand, we have 1,000, 100, 10, 1. Okay, what's the pattern there? Well, here, and by the way, these are true facts, right? 10 cubed is 1,000, 10 squared is 100, okay? To get from 1,000 to 100, we can subtract 900, but if I do that again, that's not going to get me to my next step. So instead, I need a new rule. Instead of subtract 900, a better rule is to divide by 10. So if I divide by 10 each time, 100 divided by 10 is 10. 10 divided by 10 is 1. Let's keep going. What is 1 divided by 10? Well, that's 1/10. Right, yeah, cool. And what is 1/10 divided by 10? Well, that's 1/100th. And we can, in fact, take this same rule and keep going to our next step. Just gonna move it down there. Sorry. So 10 to the -3rd power, we can predict what that's going to be. That's going to be whatever 100 divided by 10, or 100th divided by 10 is 1/1000th. Okay. Also, check out this pattern. 10 to the 1st is 10, and 10 to the -1st is 1/10. That is no coincidence. 10 squared is 100, but 10 to the -2 is 1/100. Check out 100, 100, 100, 100, 10, 10. Whoa, so cool. In fact, that same pattern continues yet. 10 cubed is 1,000, and 10 to the -cubed, to the -3rd power, is 1/1000. Whoa! Okay. That and so what do you discover? As the exponent decreases by 1, we divide by the base. Divide by 10. Isn't that so cool? Yeah, we did it. That was the pattern. Okay. Now we can use that pattern to figure out what negative exponents tell us all about. Well, here, let's look at this backwards. X squared divided by x to the 5th. Well, if we look at our quotient of powers rule that we talked about yesterday, that's the same thing as we take this minus sign right here. We get 2 minus 5. So that's x to the 2 minus 5 power, to the power of 2 minus 5. And what's 2 minus 5? 2 minus 5 is 3, but -3. So we get x to the -3rd power. Let's look at it a different way by looking at what it means to be a power. What is the definition of power? Well, remember x squared, actually I'll highlight it in a different color. X squared means x times itself twice. X times x. That's 2 of them. Boom, boom. Okay. X to the 5th is x times itself 5 times. 1, 2, 3, 4, 5. Nice. Okay. So x to the 5th is 1, 2, 3, 4, 5. Sweet. But because we're working in a fraction, we can reduce these guys out. Pew, 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 pew. Done. Giving us, that's just a 1 on top. 1 over x times x times x. Yay. Well, what is that the same thing as? Look, we've got 1 over 1, 2, 3. So that means that these guys are equal. Whoa. Because each time we started out with x squared over x to the 5th. So these two expressions must be equal. Hey, but guess what, guys? That's our rule. Oh, I didn't actually... We can clean this up. We can clean this up just a little bit. I'm so sorry. By using the definition of powers, when we have x times itself 3 times, that's x cubed. So this is the same thing as 1 over x cubed. And that's what I meant to say. That these two expressions are equal. If you ever have x to the negative something power, nope, I'm going to go with a. If you ever have any number a to the negative something power, that's equal to 1 over a to the nth power. Okay, so when you see negative n, think minus n. And we can even reverse that too. Let's say we have the same thing, but we switch it around, and we have 1 over, oops, scoot you over. This time, instead of 1 over a to the n, we put the negative here. We just take this negative over here, we put it right there. And guess what happens? These negatives cancel out, giving us a positive. But you wouldn't even write the positive because you don't need to write positive. So there it is. Isn't that such a cool rule? I love this rule. So let's figure out how we can rewrite these expressions. Okay, 10 to the negative 3rd. Remember to have, I'm just going to bring this down here. If we have any number to the negative something power, we put it underneath the fraction. So here our base is 10 and our negative number is 3. So this is the same thing as 10 to the negative 3rd is 1 over 10 cubed. But we figured that out already. We knew that. We did that up here. Ha! So this is our final answer. Let's do another one. Taking our rule, here our base is 2. And 2 to the negative 4th power is the same thing as 1 over 2 to the 4th power. We just take our 1 over, and then we put it like that in the base. And the denominator, actually, because 2 is our base, right? So when you see this negative sign right here, think 1 over, and that's what your negative in your exponent means all about. This negative means 1 over. This negative means 1 over. Okay? Awesome. Now, we're going to take all the rules we know about exponents and we're going to put them together to simplify expressions. When you simplify an expression, you can't have a negative exponent. You need to have only positive exponents. So to simplify an expression with a negative exponent, you need to write an equivalent expression with only positive exponents. Also remember, as a quick review, to simplify, you need each base appearing only one time, and fractions should all be in their simplest form. Now, guys, I just gave you a bad definition because I used simplest in simplify, and that was not cool of me. So when I say simplest, think reduced. You're reducing all your fractions. Okay, let's do it. We have 2 things, and then we're going to be done. Okay, so I put this into a couple steps for you. First, I like to organize them by their base. So I like to look at what's the big number that we're dealing with. For example, x and y are our bases. We're going to sort by base. And then we need to make sure to get rid of our negative exponents. So we're going to take that and we're going to do our rule of negative exponents. Oh, it's up here. I should just copy it. but you should rewrite it because you'll remember it better. Okay, our rule being, if you have a negative exponent, that's the same thing as 1 over the exponent, the power, and then just simplify it best you can. Okay, what's wrong with this? Well, first, what's wrong with this, guys? He's got a negative exponent, and guys, we need to keep it positive. We can do this. Let's separate them into their bases. We'll look at our x guys, and then we'll look at our y guys. Well, x is great. We can't do anything more with that. But this y to the negative second power, we can redo that. Remember, y to the negative second power, that's the same thing as y to the second power, boop, under 1. Because this negative is like 1 over something. So that's the same thing as x times 1 over y squared. We're going to do one quick more little simplifying step. We're going to take this x, we're going to hop him up there, giving us, literally, I'm going to have him hop up there, x over y squared. Final answer, all done. So what did we do? Well, we tackled it by base, dealt with our x, but there was nothing to deal with. And then we took our negative exponent, that's a 1 over, and there it is, all over, y squared. Woohoo! Let's do it again. Oh, look at this guy. Well, we need to first sort them by base. So let's separate our A problem from our B problem and see what we get. So we have A to the 5th over A cubed times B to the 1st power over B to the 4th power. Now I'm going to use my rules of exponents and I'm going to say, oh, hey, look, 5 minus 3? Crazy. That's 5 minus 3. Awesome. I'm going to do that same rule over here. 1 minus 4? That must be B. 1, sorry, wrong color. 1 minus 4. Wow. Okay, now let's hop it back to like 2nd grade or whatever. 5 minus 3 is in fact 2. 1 minus 4 is negative 3. Cool. I'm gonna take this opportunity to kind of squeeze them together a little bit. Oh, but we are not done. We have a negative exponent. Shooties magooties. Remember, a negative exponent, you take that negative, and that's the same thing as saying 1 over whatever the thing is, because the negative becomes your fraction bar, and you take the rest, b cubed. A squared is going to stay the same, giving us a squared. And now we can multiply them together by putting these two guys together. And it's a matter of saying, you know what, this a squared is just going to bop right up top. Get rid of that color coding because who needed it anyway? Bop right up top. Don't need the 1a squared. It's just that. Oh, and hey, center it. And you're done. Isn't that so much cleaner? That just looks nicer, you guys. Look how beautiful that is. That's amazing. I love it forever. Who needs negative exponents? Not me. Don't be negative. Be positive. Okay, that's cool. But we need to represent this in a normal number, like for normal people to read. Because who understands what that means? Somebody, I'm sure. Well, anyway, so you've got this bacteria. And it has a width of 10 to the negative 3rd power of a millimeter. So in normal people language, that means it's tiny. Okay, the head of a pin, for reference, you know what a pin is, like put a pin in it. That has a diameter of 1 millimeter. So now we need to find one, I almost gave away the answer. How many E. coli bacteria can fit across the head of a pin? Well, let's find out, what does this even mean? Let's start out with 10 to the negative 3rd. Go away. Well, that looks gross to me, but I know a better way to write that. I take my negative exponent, and that's just the same thing as 1 over that expression, because the negative converts itself into a fraction bar. So that's 1 over 10 cubed. In my soul, I know that looks better, but I still don't know what this means. Fortunately, I know what the third power means. That's the same thing as 10 to the third power is just 10 times itself 3 times. 1, 2, 3. Awesome. And 10 times 10 times 10, I know that is 1,000. Boom. So that right there, that is 1/1000th of a millimeter. Okay. So if a bacteria is just one of them, if it's 1/1000th of a millimeter, and a pin is 1 millimeter across, how many can fit on the head of a pin? Well, you can fit 1,000 of them. You can have 1,000 bacteria on a pin. You guys, pins are tiny. Wash your hands. Okay, key idea of the day is that negative exponents, if you ever have a negative exponent, it's just the same as 1 over the positive exponent. And then you're not allowed to have negative exponents, so make sure you don't have negative exponents. You always have positive exponents, and all fractions are reduced. Oh, and each base is only once. And that's how you know something is simplified. Okay, have a great time on your homework. Whee!